Another few examples coming your way. And this next one is going to require the use of some kinematics in addition to the stuff we've been playing with so far this lesson. Example number 5. A 2.5 kilogram rock falls from the top of a 40-meter high building and strikes the ground below. What is the force, magnitude, and direction of the ground acting on the rock if it comes to a stop in 0.350 seconds? So what's going on here? Again, thinking back to kinematics, I'm at the top of a really tall building, 40 meters. And my rock is going to fall downward. Now, as it falls, it gains speed until, of course, it hits the ground and eventually ends up at 0 meters per second. Part that involves the kinematics, though, doesn't stop at the 0 meters per second. It stops right before the rock hits the ground. So we need to remember some of our kinematics in order to make this work. So I've got a mass, 2.5 kilograms. And the rock falls from the top of a 40-meter high building. Now, this 40-meter high building is the height of the building. It's actually not quite the displacement of the rock. If you remember, the rock is falling downward 40 meters, so the displacement of the rock is actually going to be a negative 40 meters to indicate that it's falling and strikes the ground below. Now, the kinematics part of this question also requires you to remember that a rock that falls, it's not thrown, it just falls, is going to have an initial velocity of 0. And because we're talking gravity, we're talking Earth, we're going to have an acceleration downward, so negative 9.8 meters per second squared. Hopefully we can use these 3 pieces of information to find my V final. And my V final for kinematics is actually going to be my V initial for bringing the rock to a stop. So we'll deal with the kinematics first and then come back and do the impulse part. So with this information, I know that I'm looking for this equation, that's V final squared equals V initial squared plus 2AD. And to solve for V final, all I have to do is take the square root. So that gives me V final is square root of, well, V initial was 0, so that kind of goes away, plus 2 times negative 9.8 times negative 40. Now you'll notice that if you forgot both negatives on there, it would actually work out okay because 2 negatives are going to make a positive. But you'd have to forget them both. You couldn't put the negative with the 9.8 and not with the 40, or you're going to have trouble when you're square rooting. But when we square root, we do want to remember that my V final is going to be downward. It's actually going to be the negative root. So this is going to be negative of whatever it is that my calculator gives me when I plug that in. So go ahead and take out your calculator and plug in square root of 2 times 9.8 times 40. And that gives me, exact answer. Well, 28 meters per second downward. It's going downward. So this V final, which is my V final for my kinematics, is actually going to be my V initial in terms of my impulse stuff, because it starts at negative 28 meters per second and ends up coming to a stop, which would be V final of 0 in 0.350 seconds. And this math that I wrote down at the beginning is actually going to be most useful down here. And what are we looking for in the question? They actually are looking for the force. What is my force? So at this point, this information will let me use that equation that I've been using already. Force times time is mass times V final minus V initial. And I'm looking for force, so I'm just going to divide by time, same as I did before. So I've got force equals mass, so that's the 2.5. V final is 0 minus negative 28 all over 0.350 seconds. So again, pull out your calculator. 2.5 times 28 divided by 0.35 tells me my force is exactly, look at that, 200 newtons. Now the fact that I get a positive answer, and this should make sense in the context of our question as well, is that my force, the direction of my force, remember I need magnitude and direction, is going to be 200 newtons upward. And this little dot is what gives me my 3 sig figs, because when you have a decimal, then your zeros start to count. So this is going to be 200 newtons up for my final answer. So you can see how each time we're adding kind of a layer of complexity, not stuff that you haven't seen before, but a few more steps to get you all the way to the final answer. Let's take a look at another one. Example number 6. A 4.2 kilogram ball moving at 4.65 meters per second east hits a wall. The wall exerts a force of 350 newtons to the west for 0.0750 seconds. Find the final velocity, magnitude, and direction of the ball. So what's going on here is I've got this wall, and I throw a ball at it towards the east. So my ball is moving at 4.65 meters per second, hits the wall, rebounds off the wall, comes back off, going to the west. Don't know if it's going to go, probably going to go a little bit slower, so maybe I'll make that vector a little bit smaller, but I don't actually have any numbers yet to put to it. But it bounces off the wall and goes back in the other direction. Now again, we need to keep track of things like the fact that east is going to be a positive 4.65 meters per second, but the force on the ball is going to change its direction towards the west. This is actually going to end up being a negative 350 newtons. Because my force of the wall on the ball is going to accelerate it west, is going to be negative 4 to the west. And we're looking for final velocity, magnitude, and direction of the ball. So again, I'm going to combine this. Ft equals mvf minus mvi. And I want to find vf. So I'm going to add mvi to both sides. So ft plus mvi equals mvf, and divide by m. Finish it off. I guess I should have written down my data. Sorry, forgot about that. Let me move this one step back for a second. Move that over. Okay, so my mass, 4.2 kilos. Initial velocity plus 4.65 because it's going east. Wall exerts a force of negative 350 newtons because it's west, and time is 0.075 seconds. All right, so I should be able to plug in my numbers now. Ft plus mvi over m. So force negative 350, time 0.075, plus mass 4.2 times initial velocity 4.65, all divided by my mass of 4.2 all over again. Take that, type that into your calculator, and see what that gets you. And what that gets me is negative 1.6 meters per second, which makes sense. It should be negative. The negative actually tells me I'm going at 1.6 meters per second west, which is what I would expect in terms of bouncing off a wall when I was going east, turned around, now I'm going west. So again, watch out for those negatives. They are going to be important. East is positive, west is negative, up is positive, down is negative, all that good stuff.